Alright everyone, today we're going to be talking about the quadratic formula. Today we're talking about how to use and interpret the quadratic formula. If you'd like to know more about the origins and history of the quadratic formula, that will be in a separate video linked in the description below. This is the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It's used with the general form of a parabola, ax squared plus bx plus c. In order to use the quadratic formula, you will take the coefficients from the parabola's formula and you will plug them into their corresponding locations. The a coefficient goes to the a's, the b coefficient goes to the b's, and the c, which is a lone coefficient, goes to the c. Now let's work an example. If we take the parabola y equals x squared plus 6x plus 8 and set it equal to 0, as is done here, we'll notice that this would be a very easy problem to solve. We would just factor it into binomials. That would give us x is equal to negative 2 and negative 4. Now for a proof of concept, let's plug this into the quadratic formula since we already know the answers. Here's our quadratic formula, and we would start by figuring out a, b, and c. A is going to be the coefficient for the x squared term. That is going to be 1. We just have an x squared, so that coefficient is going to be 1. B will be our coefficient for the x term, be 6. And c will be our lone coefficient, or our x to the 0th power coefficient, which is 8. Next, we're going to plug them into their corresponding locations, as we see here. And now that we've plugged them in, let's begin to process this. And one more step to process it, that would give us negative 6 plus or minus the square root of 4 over 2. Square root of 4 is 2, so that's negative 6 plus or minus 2 over 2. We can actually divide that 2 out. In the next step, it'll give us negative 3 plus or minus 1, which is negative 2 and negative 4. Those numbers look really familiar, don't they? That's because it's the exact same as when we factored them into binomials. Proof of concept for the quadratic formula. Now let's take the quadratic formula and break it down a little bit. This part circled here, b squared minus 4ac, determines a lot about the parabola. This is referred to as the discriminant. And from the discriminant, you can determine if you have one of 3 situations. If the discriminant is positive, you're going to have a parabola with 2 real x-intercepts, or zeros. If you have a discriminant of 0, then a couple things you know about your parabola. For one, it is going to be the square of a single binomial, so like x minus 5 squared. You also know you're going to have one real 0, or x-intercept, and it will have a multiplicity of 2, which means mathematically it occurs twice. However, on the graph it's going to look like it hits the x-intercept and bounces off. And you can also have a negative discriminant, which means you will have 2 imaginary x-intercepts. In order to write this, you'll leave this in the form a plus or minus bi, where I is the imaginary number, the square root of negative 1. Alright, now let's work an example in situation 1. We'll start with the parabola x squared plus x minus 12. Then we'll take the general form of the discriminant b squared minus 4ac and plug in the coefficients where they belong. So then 1 squared is 1. 4 times 1 times negative 12 is negative 48. 1 minus negative 48 is 49. That's a positive number, which means we're going to have 2 real zeros. We know this. Now let's plug this into the quadratic formula and prove it. So we know the discriminant is just b squared minus 4ac underneath the square root. So we can plug the 49 in directly there. The 1 goes to the negative b, and the other 1 goes to the a. Square root of 49 is 7. And then we get 3 and negative 4 for our zeros, our x-intercepts. That's 2 real zeros. Now I also graphed this on a TI-84 emulator, screenshot of the graph, and you can see 2 real zeros, 2 real x-intercepts. Now let's work an example from situation 2. So we have y equals x squared minus 10x plus 25. Let's take the general form of the discriminant and plug in our variables. So we have negative 10 squared, that's going to be 100, and then 4 times 1 times 25, also 100. 100 minus 100 is 0. So we have a discriminant of 0. That means we're going to have 1 real 0 with a multiplicity of 2. Now let's plug this into the quadratic formula. Then we'll end up with 10 plus or minus 0 over 2, which is just going to be 10 over 2, which is 5. So there's our 1 real 0. There it is graphed. You can see the graph kind of impacts the x-axis at 5 and bounces. Now actually I mentioned earlier that this occurs when a parabola is a square of a binomial. So let's actually see that. If we factor this one out into 2 binomials, it's going to be the same binomial twice. And we can see where that multiplicity of 2 comes from. Alright, now let's work a situation 3 example. So we're going to start with y equals x squared plus 2x plus 5. We're going to take our general form of the discriminant, and we are going to plug in our coefficients where they belong. 2 squared is 4. 4 times 1 times 5 is 20. 4 minus 20 is negative 16. We have our negative discriminant here. So a negative discriminant means we're going to have 2 non-real or imaginary zeros. Plug that into the quadratic formula and see what it looks like. So we know we can just plug our discriminant in underneath the square root. And then we're going to end up with negative 2 plus or minus square root of negative 16 over 2. So square root of negative 16 we can break up into square root of 16 and square root of negative 1. Square root of 16 is 4. Square root of negative 1 is the imaginary number, that is I. Then we're going to end up with negative 2 plus or minus 4i over 2. We can divide that 2 out. We'll end up with negative 1 plus or minus 2i. Then if we were going to break that down further, we'd end up with 2 imaginary zeros, negative 1 plus 2i, and negative 1 minus 2i. So these are both potential answers. The top one is that a plus or minus bi form. Sometimes you will be asked to deliver your answer in a plus or minus bi form. Sometimes you'll be required to give out both zeros. So then if we're going to see what that looks like on a graph, it is going to be a parabola that just never intersects the x-axis. So we have no real zeros, 2 imaginary zeros. I hope you found this video informative. If you would like to suggest a future video, be sure to sound off in the comments below. Thanks for watching.